So now, speed and velocity. Like I said, velocity is a vector quantity. So here's a vector. We'll call it v. It has magnitude, the length. It has direction, the orientation. And it's very difficult to measure something as an instantaneous event. So we need to know something about how the units are put together. So the units, I will denote units in brackets. So it has units of length divided by time. Those are my units, and in our convention, that's going to look like meters per seconds. It doesn't really matter. It could be furlongs per fortnight. I don't really care how you do that, but it's got to have units. Velocities have units. Okay. Length per time. Now, velocity involves construction of something about the change in position and the change in time, as denoted by units. So velocities are defined by an r vector that's changing and a t vector, or a t scalar, that's also changing. So, speed, which is what you record in your speedometer in your car, is the magnitude of the velocity vector. And so to construct my vector, what I can do is I can take the speed and multiply it by the velocity unit vector. So this tells me which direction I'm going, and this tells me how fast I'm going. Either of these two things can change. This could have a delta, and this could have a delta. It turns out that having something's direction change means that its velocity vector changed direction. If its speed remained constant during that, it still would have had a change in velocity. And vice versa, if I'm going in the same direction but speeding up, I'm also changing my velocity. It means I've had an outside influence. So let's do an interesting example of this by looking at a simple graphical representation of going on a bit of a trip. And so I'm going to draw a position line. This is x increasing. Okay? And now I'm going to denote where I am in time along my x as I take steps here's my position, x1. And I'm also at time 1. Okay? Here's where I am at x2. Position number 2 at time 2. Here's where I am at position x3 at time 3. And here's where I am at x position number 4 at time 4. And then I take a trip back and I say, here's where I am at time 5, also at position 5. So I sort of go out, I come back, and then I come all the way back. So what does that look like graphically? Let's graph our positions and our times accordingly. So I'm going to put position on this axis, and I'm going to put time on this axis. And then I'm going to look at my positional change, and I'm going to also look at the directions that I'm going. So let's say this is the intersection of T1, T2, T3, T4, T5, X1, X2, X4, X3, X5. How does that now look? All right, so let's see. Let's see how that goes. So I start here. I move towards 2. I go up to 3. I head back down to 4. And then undergo some interesting changes until I get back to 5. So, let's put here. So now, I have to make an adjustment here. Okay, so let's look at our average velocities. So the average value, the value of my velocity, is indicated by the change in my velocity over a change in time. So the average velocity is going to be the change in my position, change in my position from x1, let's say, to x2. So delta x2 to 1 is going to look like x2 minus x1 over t2 minus t1. So here I'm increasing my position, and time is of course always increasing, so this is greater than 0. All right? How about another time window? Let's take the time window delta x, this is delta t, to 1. Let's look at the, and this is the average velocity from 2 to 1. How about the average velocity these are all vector quantities. Average velocity from 5, 1. Delta x 5, comma 1 over delta t 5, 1. Well, this is going to give me delta, so x5 minus x1 over t5 minus t1. What's that equal to? Well, where did I start? I started here and I ended here. So in terms of my average velocity, that's equal to 0 for the whole trip. My average velocity is actually 0. It's a little hard to believe, but it's true. The time is still the same, but the change in position, this change in position is identically 0 because I've ended at the same point where I began. Okay. What about my average speed during that time? Let's say that my round trip to go from here to here to here, back to here, and then back to here, let's say that was 300 meters. The length of this curve is 300 meters. So what's my average speed? So V average, the magnitude of that, well, if it took me 300 seconds, if this time interval here was 300 seconds, well, that's going to be 300 meters divided by 300 seconds. My V average is 1 meter per second, which is very different than 0 average velocity. Average speed, and this is from 5 to 1, that's going to be 1 meter per second, which is pretty nice. Not 0.